Okay, so this is the last problem that is dealing with concepts. Everything after this will be practicing problems. Explain how you know where the vertical asymptotes and zeros are for the function cotangent of theta. Well, think about what cotangent is. Cotangent of theta is defined as, using this quotient identity, cotan is cosine of theta divided by sine of theta. Well, this is a fraction. Think about how fractions work. These fractions will be undefined when the denominator is 0. When the denominator is zero, giving us an undefined value, that means we will have a vertical asymptote. So we'll have a VA when sine of theta equals 0. And we will have zeros when cosine of theta equals 0, because when the numerator of a fraction is 0, that whole fraction is 0. So think about the unit circle. Again, I always just come back and draw myself a unit circle. List the values of theta on the interval negative infinity to infinity, where f of theta has zeros and where f of theta has vertical asymptotes. So again, think about what we said. Let's do the VAs first. Vertical asymptotes will occur anytime the value of sine is 0. Sine is your y value, so that will occur here and here at 0 and pi. But that's only if we're looking specifically between, let's say, 0 and 2 pi. But we can continue to make revolutions around for as long as we want. So we need to define this algebraically. So we need to say the vertical asymptotes will occur at these values. And how do we write it? Well, we can say a times 2 pi, comma, for some, backwards e means for some a in the set of real numbers, but it needs to be more than real numbers. We need to say it has to be in the set of integers, which we denote with a capital Z. Now, what does this mean? This means that all multiples of 2 pi, I goofed this up. That should actually say multiples of pi. Poo-poo. Think about why that is. We're saying that any multiple of pi will give us a sine value of 0. Does that make sense? Sure, 0 is the same as 2 pi, so if a was 2, then we'd get 2 pi. If a was 0, we'd get 0, which has a sine value of 0. If a were 1, we'd get pi. If a were 3, we'd get 3 pi, which is the same as pi. If a were 2, we'd get 2 pi, we already said that. If a were 4, we get 4 pi, which is the same as 2 pi. The point is, we'll be jumping back and forth between those 2 points. So at all multiples of pi, we will have, all integer multiples of pi, we will have a vertical asymptote. So if the notation is too much for you, you can just explain it to me. Say, all integer multiples of pi. Now it has to be integers though, because if I multiplied it, say, by 0.5, if a was 0.5, well, that give me pi over 2, and sine is not equal to 0 at pi over 2. So all integer multiples of pi will give me vertical asymptotes. Well, what about zeros? So for zeros are occurring when cosine is 0. So when is cosine 0? Well, cosine 0 when it's straight up and down. So at pi over 2 and 3 pi over 2. So when will we have multiples now? Well, now it's going to be the same exact thing. We're going to have multiples as we continue to do full revolutions around and hit those 2 points, but it's going to be a little bit different. This time we're going to say the multiples need to be the same idea, a times pi, but now we also need to add to that pi over 2. And again, that's going to be for some, actually, we should say That is for all, an upside down A is for all A in Z, because this is true for any A value that we can plug in. So I'm going to change this over here back, change that to a for all A as well. It's a small distinction, but it's important nonetheless. Now what is this saying? This is saying, if you think about all integer multiples of pi getting us to either 0 or pi, well, if you add pi over 2 to that, then you get to those corresponding parts straight up and down. So this is going to be all integer multiples of pi plus pi over 2. Because again, think about what happens if A is 0. If A is 0, A times pi is 0, and we add pi over 2, we're straight up and down. If A is 1, then we get pi plus pi over 2 is 3 pi over 2, and we're straight down. If A is 2, then we get 2 pi. Well, 2 pi is the same as 0, and then we add pi over 2, and we're straight up again. Make A 4, and then 4 times pi is, again, the same as 2 pi. And we're there. What about 5 pi? Well, 5 pi is the same as pi, and then add pi over 2 to it, you're at 3 pi over 2 again. So the whole idea is that A times pi represents half revolutions around the full circle. So going 180 degrees, going pi. Every time we jump that far, then add pi over 2 to it, we've gotten ourselves up or down. And that's what we're looking for.